Hello everyone and welcome to the channel of farmerboy. A little bit about me. I'm a competitive programmer who is currently working as a software engineer. This is my first ever YouTube video and today we are going to talk about selection sort, a sorting algorithm. Let's dive right in. First of all, a brief explanation of selection sort. Let's assume that we have an array of numbers that we want to sort in ascending order, like this. The algorithm will maintain two subarrays, the sorted part and the unsorted part. Let's say the sorted part starts from the leftmost element, meaning smallest element in this case. The algorithm repeatedly selects the smallest element from the unsorted part and swaps it with the leftmost unsorted element, effectively growing the sorted part by one element. Initially, the sorted part is empty. After each iteration, the smallest element from the unsorted part is selected and moved to the end of the sorted part, making the sorted part grow while the unsorted part shrinks by one element. At the end of the process, the unsorted part becomes empty, and we're left with a fully sorted array. Next, let's examine selection sort with a demonstration on a real array of numbers. We have it described by the heights of the bars right here, with green boxes for the sorted part, blue boxes for the unsorted part, yellow box for the current minimum value during iteration, and red bordered box for the iterator. We start with the first iteration to put smallest element into currently empty sorted part. Initially, the smallest one is the first one, 64. As we proceed with the next elements, we update the smallest element to 34, 25, and 12. But with 32, it's not smaller than the current smallest element 12, so we don't update that value here. Then to 11, we update the smallest value, obviously. Finally, 90 and 88 are way too larger than the smallest value, hence we don't update it. After the first iteration, we found 11 as the smallest value, so we swapped it with the leftmost element in the unsorted part, which is 64. Now the unsorted part shrinks by 1, and the sorted part grows by 1. The second iteration, we start from the second element. We do the same thing as the first iteration to find 12 as the smallest element. Once again, we swap it with the leftmost element in the unsorted part, which is 34. Now the sorted part has two elements. Then in the next iteration, we find 22 to be the smallest value, then next iteration 25, then 34, then 64, 88, 90 respectively. The sorted part keeps growing while the unsorted part keeps shrinking. Please note that we don't swap when the smallest value is already at the leftmost side of the unsorted part. Eventually, we have a fully sorted array. Finally, let's explore the implementation. Here I have an implementation in C++. The function receives an array and will do sorting on that array. We shall maintain the index of the smallest value, then find it within the unsorted part. At the end, we swap values at the leftmost index of the unsorted part and the index of the smallest value. We do two for loops here with the max size of n in each loop, so the time complexity is O(n) squared. But we don't create new arrays, so the space complexity is O1. This may change to O(n) if you want to preserve the input array and create a new array for the sorted outcome. One observation with selection sort is that you can choose to start sorting from the smallest elements, like in the animation here, to the left side first, as usual, to exhaust the unsorted part on the right side. At the end, you will have your sorted array, just like you can see here. Or you can choose to start sorting from the largest element, the right side first, to exhaust the unsorted part on the opposite side, which is the left side, as you can see. Both ways are fine, as long as you can understand what you're doing. That's it. Thank you so much for watching. Please like, share the video, as well as subscribe to my channel to receive notifications about latest videos, sharing about algorithm knowledge in the future. I'll see you in the next videos.